CO2 radiocarbon analysis to quantify organic contaminant degradation, monitored natural attenuation, and engineered remediation approaches, ER 2338, was a 3-year effort to demonstrate technologies for measuring in situ contaminant degradation. The technique relies on the fact that industrial chemicals, up until very recently, have been made with petroleum feedstocks. Petroleum, being fossil-derived, is devoid of C14, which has a half-life of around 6,000 years. Any C14 in plant material undergoing diagenesis over millions of years will be completely decayed away. The fossil signature can thus be tracked into the ultimate degradation product of organic contaminants, namely CO2. CO2 is quite easily captured using sodium hydroxide traps, which can be deployed within a groundwater sampling well headspace. Collected over time, CO2 can be quantified to obtain a respiration rate. It can also be analyzed for radiocarbon using accelerator mass spectrometry, AMS. Using a 2N member mixing model with natural CO2 radiocarbon content from background, i.e. non-contaminated wells, the percent CO2 at a given well arising from contaminant versus the natural organic matter can be calculated. Coupling respiration and percent fossil derived CO2 gives the rate of contaminant degradation. A zone of influence model can be created to estimate the volume in cubic meters sampled by the well headspace traps. These models use hydrogeologic parameters taken on site from soil borings and data collected during well installation activities. Ultimately, the technique provides the mass of contaminant degraded per unit volume per unit time, e.g. the grams degraded per cubic meter of soil per day. The technique was applied at 3 sites at the Naval Air Station, North Island in San Diego, California. IR5 Unit 2 showed significant chlorinated solvent degradation, as much as 400 milligrams TCE equivalents per cubic meter per day. By interpolating over the entire TCE plume, up to 70 grams were degraded per day. At OU19, TCE degradation averaged up to 19 milligrams per cubic meter per day, with nearly 5 kilograms degraded per day when interpolated over the entire plume, which is estimated to be thousands of kilograms in quantity. At OU20, rates were lower, with an average of only around 1 milligram TCE degraded per cubic meter per day. OU20 was the largest overall site, 116,000 cubic meters, with around 1 gram TCE degraded per day over the entire plume volume. The ER 2338 technology demonstration is significant in that radiocarbon depleted CO2 can be definitively tied to the contaminant carbon backbone, thus represents a direct measurement of in situ degradation, in contrast to multiple lines of evidence which may indicate but do not prove in situ degradation is occurring, or offer direct rate measures. Radiocarbon analysis may be considered relatively expensive compared to other single analytical measurements, but as stated is definitive, and with advances in technology, costs are becoming very reasonable. For instance, gas source AMS measurements are now less than $60 each. At this level, the cost-benefit ratio for this technology is very high.